Thrilled to be here again for this part 2 of fractions, which you can view on the Braining Camp site. There's a tab now for webinars. And so you can go to that tab and see previous webinars. There's introductory ones for each grade band. I did one on the progression of addition, kindergarten through 5th grade. And also the part 1, where I covered the content standards, kindergarten to 3rd grade, setting a foundation of conceptual understanding that tonight will go into the grade 4 and 5 standards. So we're going to talk about equivalency and comparison, a little harder way of comparing, as well as the 4 operations. So it's a tall tale to cover this all in an hour. It is a lot of content, but when we understand the progression through grade levels, it can really make sense of how we're building a foundation for the next grade, and also how to fill in those things as well, finding out where our students are on that journey and helping them move forward. So thrilled to be with you here tonight. My name again is Annalise Record. So happy so many of my friends are here as well. I feel the love. Thank you, everyone. The chat bar went really quickly, so I couldn't read all the comments to see all of you that are here, but thrilled to have all of you here. So part 2 tonight, the fractions are going to focus on grade 4 and 5 standards. I am an independent math consultant. I live here in Concord, New Hampshire, and I want to let you know I do have an online presence because we were living in northern New Hampshire for over 20 years. And I found this community of educators online. There's an amazing math ed community on Twitter and on Facebook as well. And sharing ideas, we're all better together. It's not that anyone's better than math than anyone else. I've just been on this journey longer, and I've built the pathways in my brain to understand these things. So just being able to share that knowledge and share it to help all of our kids and ourselves feel more comfortable with math. I do have my own webpage, annaliserecord.com. You can subscribe even to my newsletter. I do about twice a month because I know you don't have time to be searching through all the social media posts of these wonderful resources that are available. And I don't have the time, but I make the time because I love it. And I'm happy to share everything that I'm learning. So please feel free. There is a code tonight. It's called second half. You do need to redeem it tonight, but it will be giving you access for yourself and your students for 45 days of Braining Camp. So super generous of Braining Camp to offer that for all of you. So again, it's called second half. And please do redeem that tonight. You can feel free to put any comments in the chat bar. I've got my team behind me here, Mark, Dan, and Ryan. They'll be answering your questions in the chat, and then they'll keep an eye on that for me, so that at the end, I'll be happy to answer any other questions that you have. But my goals tonight, number 1, is to focus on the mathematics of fraction and fraction understanding, as well as the development of fraction concepts for grades 4 and 5. So focusing in on those content standards, and of course, how Braining Camp's set of virtual manipulatives can help us make this thinking visual, so our students can then be seeing the visual models of these concepts so that they can then visualize, and it can unlock the math journey for so many more of our students. And this is for every student's brain. This is not just certain kids who need manipulatives. It's for every single brain. So I do want to focus on equivalent fractions. I'll be using the GeoBoard and Fraction Tiles apps. Comparing fractions, I'll be showing you fraction tiles, the number line, and GeoBoard as well. Decomposing fractions, huge thing, really important to help us with the operations to have that decomposition. And then the 4 operations. I do want to go through examples for each of the 4, including also in that Quiznarods as well. And we'll have time for questions and answers as well. So feel free to add those in the chat bar. So what emotions do you feel when you see this equation? So 3/4 times 5/6, right? So for many people, what goes through their mind is, all right, wait, do I multiply numerators and multiply denominators? Do I keep flip and change? Oh, wait, no, do I keep denominators the same, right? When we've taught and learned fractions in a procedural way, we get to a point where when we see something, we don't remember what that procedure was. It's not attached to anything in our brain to attach to that learning. So we want to make sure that we're exploring these concepts in ways that we understand why those procedures are working. It can become a shortcut, but we want to make sure we know the why. It's all about the math, elementary math education is the why, and not just getting right answers. We want to value the process as much. So some people, a few people are like, oh, that's easy, right? And then for many, fractions strikes a stake in their heart. I see it in their faces when I'm doing presentations for parents, for the districts that I work with, or even doing trainings, particularly with the primary grade level teachers. I can see the fear come across their face when I show them a fraction. But I want to show you tonight some ways we can explore fractions that will unlock this journey for everyone. It's not a matter of having a math brain. There's no such thing as a math brain. So fractions has been a gateway concept. For many, when I meet people in my consulting work, over 80% of the people have hated and despised math their entire lives. And when I ask them why, it's one of two reasons. One is the math facts that killed them. That's why a lot of my work is on fluency, because we can change that. But the people that weren't caught at the math facts, they get caught in fractions. And so thinking about exploring these numbers, when we explored numbers, whole numbers from the start, kindergarten to the third grade, there's a whole journey of exploring the whole numbers. Well, the journey begins again in grade 3 when we introduce fractions. Verbal counting, object counting, decomposing, supertizing, all that again comes in play with fractions. So we're building the number sense for fractions, as well as in decimals, of course, as well. As we are exploring things, it's going to happen gradually as a result of exploring numbers and visualizing in a variety of ways. So not just one math tool, but many, and relating them that are not limited to traditional algorithms and procedures. So it's not just limiting to do it this certain way, but we can think flexibly about numbers. So I'm hoping tonight to show you some ways that will unlock that journey. Perhaps if fractions wasn't a favorite thing for you. Of course, I'm a huge fan of Joe Bowler's work and growth mindset, the idea and the science behind that our brains can grow and change. They are plastic. They can grow and change. And if you go down a beach path once, the grass would regrow, right? But if you go down that path over and over again, it becomes a permanent pathway. This is what's happening in our brains. When we are learning something new, we're attaching it to what we already know. And the more that we practice and keep that thinking, it becomes permanent pathways. And we're building these pathways in our brain, and we literally are changing our brain. I know I've lived through this. When I was a kid, I learned rote procedure and memorization and formulas, and I did great. I thought I was a math person. But on my journey, the last 10 years of elementary math and this in-depth learning, I think differently about math. So I was, when I learned, I thought I was, a good math person. Well, now I know that I didn't know before, the conceptual understanding, but now that I do. But I have changed my brain as well as my husband's and, and my parents. They always tell me, I think differently now, hon. My kids kind of had their own brains. They're amazing. But okay, so I want to unlock the door. I want this to be an unlocked door. Welcome everyone into the math journey with fractions. So, all right, so let me go to the Braining Camp app for a second. I know many of you may, or some of you may be new to the Braining Camp. And so I wanted to share one of the apps with you just to get started, explain the commonalities between all the apps. You'll notice the Braining Camp offers at the moment 16 apps. These cover content from kindergarten all the way on up. Of course, using manipulatives, exploring math concepts in concrete, pictorial, and abstract ways will unlock the understanding for all of our kids. It's not just certain kids that need them. It's every brain needs them. And right here at your fingertips, you have access to all of these. So you'll notice here that I'm going to go to the Pattern Blocks app. I want to share with you a little bit what's on the screen. So the manipulatives usually appear on the left-hand side. Some of them have it across the top, but these manipulatives here allow you just to drag and drop. And once you've landed it there, you can move it wherever you'd like. You can then pull out any more that you want. You're dragging and dropping. You also can just click and it will kind of put it nearby where it intuitively knows where to put it. And then if you want to copy these, you can put a rectangle around them and you'll get different options. So various apps have different options among here. So I can copy it and then everything in that rectangle there can be copied. I also could delete it in that way. So really easy, just drag and drop, use them as groups, and then you can feel free to highlight even parts of it. If I just want to do these two parts and move it, we can, all that flexibility. So the manipulatives here are for you to grab. Down below in this particular app, there's a button that can toggle between having no background or the triangles back there. This button here is for transparency, allows them to appear transparent. And over on the right-hand side for this app, it offers the text feature. So every app has that text feature, but other apps have other options down below in this bottom bar. And every app has these work mats. So there's in this particular app of Pattern Blocks, there's a basic, there's one for fractions. So it offers the fourths and the 12ths pieces. It also has a deci that would allow in tenths. So be aware as you go into the apps that there are a variety of work mats. There's some hidden gems in those. Every app also has the pen. And with the pens, you can choose your color. You can choose how wide you want the pen to be. There's the eraser, of course, and also a highlighter. So, and then in the very bottom left, there is a button to clear all. So if you find that you want to get everything off the screen, you can clear all. And new this week, hot off the presses, is the undo and the redo. So the apps now all have that. So if a student happens to do something and then they realize they didn't want to do that, they can undo it now. So the Brady Camp engineers are amazing, and they are constantly making amazing growth and growth and changes to the app. So stay tuned. It's just a awesome journey. Alrighty, so also just want to show you one more thing in the apps, that on the very left-hand side, these top two buttons will get you back to the main screen, the main Braining Camp with all the apps. This button here, tutorial, every app has a 1 to 2 minute silent movie that will be explaining and showing you various features within the app. It isn't exhaustive for every single thing you can do, but it is, you know, really nice overview. Students enjoy watching that as well. Here is a page on Braining Camp that provides you ideas for all kinds of grade levels and apps. So they're not organized yet by grade level. So just scroll through the entire page so you can see all the different ideas there. So that's super helpful as well to know that that is there. And I do want to let you know about one of my favorite features, which is the share feature. So when you do the share, let me just drag out for a second a couple of these. So if I were to have some apps on my screen, some of these manipulators on the screen, when I hit this share button, I get the choice of getting a link or copying the image of my screen, or I can even download it as a file. So if I were to choose to get the link, I just clicked on that one button to get the link. You'll notice that we have a web page here and the code down here. They are the same. I prefer to use just the share code. That's just all the kids are usually already logged into Braining Camp, and so just using the code is fine. I would use this button to copy that code. And now if I go back out to the main app screen, down below under this, it says share code. All I have to do is paste that code that I had. When I say go, it brings me into the app that I was in and what was on the screen the moment that I pressed share. So this is not like Google environment where you can watch things happen instantly. The way this is working right now is we have these share codes that allow you to put a task on the screen. You can use text, you can use any of the manipulators that you want there. And then when the students get that code, they can then manipulate the screen. They can be adding more things. They can be explaining their thinking. And then they would create a new share code and share that code back with you. And that way you could communicate back and forth with the kids. So what I have done in my journey, I provide professional development for schools that have purchased Braining Camp. And so I wanted to facilitate my sessions with them and to have already a beginning set of codes and share codes. What's wonderful is the share codes never expire. So once you have those share codes, you're moving forward. As long as you have an access to Braining Camp, then you have access to those codes. So you can share with colleagues. You can be, of course, sharing them, and share them with the students and have them moving forward. So what I'm going to do is I'm going to put this code into the chat bar. It is a Google document that I created, and I've made it so that you need to make a copy of it. But what that means is that it is yours, and you can edit and change it however you want. You can rename it. It is then yours. So if you follow that link in the chat, it is just found at, it's a tiny URL, Braining Camp Fractions Part 2. And then that will bring you into making a copy of this document. So what I've done is I've shown the concepts I want to go over tonight, as well as these share codes are going to be already have things on the screen. It allows me to have this time be most impactful without me having to create things and type things in a text bar. So it's just a quicker way tonight to help me facilitate this session, but it's also modeling for you the way that you can be assigning things to your students. All right, so first of all, I'd like to begin talking about in grade 4, the equivalent fractions, the idea of us exploring equivalent fractions. So all I'll do is I'll copy that code. I'm going back to the Braining Camp screen on the very bottom. I paste in that code. And when I say go, I've done this example here in the GeoBoard. Now, with fractions, it is so important that our students are constructing their understanding, that they are doing the partitioning. So when I use things like fraction tiles, I like sometimes not to have the numbers on them because I want the kids always thinking about equal size pieces, partitioning them, that the name of one piece being that unit fraction 1 of that size. And so in the GeoBoard is the way that I found to be able to work with the fractions and doing the partitioning myself, to really get that feeling for what's happening. I love paper folding. So when you're doing that in person with kids, paper folding is one of the favorite things I love to do with that. But when we get to this pictorial level here, I'm thinking about equivalent fractions. So here I've made a square and I'd like to partition it in half horizontally. So I can bring down this rubber band and I can see that 1/2 that we started with has now become 2/4. And so I can just record that with my pen. I'm sorry, I'm horrible at this. Dan Harris is so good at this. I'm not. So that's 2/4. Having this one here, I want to partition this into thirds. So I'll be bringing down my bands here. Okay, so I can see that now by partitioning it 3 ways horizontally, that my 1/2 has now become 3/6. And so I'll just record that. And then when I have my fourths, I'm partitioning it in fourths over here. I'm going to, again, I'll get the rubber bands and I'm partitioning it. Certainly pictorially, as students are drawing these themselves, please always call the students on the equal size pieces. When they are partitioning, they need to make sure they're equal size pieces. We can't avoid that. We need to make sure they understand that they're equal size pieces. So and precision is one of our 8 math practices. We've got to be precise. So what happened here? I partitioned it 4 ways horizontally, which means my 1/2 became 4/8. And so what was happening when we think back to each of these situations, right? I had one piece and I broke it into 2 pieces. So the one piece that I had has been burst into 2 pieces, right? And which means that the 2 pieces in the whole also were broken into 2 pieces. So I was multiplying by 2, right? They became 2 times as much. So my one piece that I had became 2. My 2 pieces that were in the whole then became 4. What happened with our partitioning it into thirds? Well, the one piece that I had was broken into 3 pieces, and the 2 pieces in all was broken also into those 3 pieces, which means why we have the 3/6. So yes, certainly it is true that we can be multiplying by the same number, numerator and denominator, but rather than just telling the students that you can do that and you'll get a correct answer, which is true, but there's an illusion of understanding there if they'll forget why they're able to do that, right? But if they've gone through the experiences of partitioning and noticing the patterns, they go, oh, when I'm putting it through a fourths experience, I'm putting this one piece that I have, it gets into 4 pieces, which means all the pieces in the whole also get partitioned into 4 pieces, which means I get my total of the 4/8. This is critical because in grade 5, we're going to be doing things with common denominators by comparing and adding and subtracting. And so we're going to need this skill, but again, it happens gradually over time. It's not just one day I can teach you multiply by the same number and now you understand that, right? So also thinking about equivalent fractions, I want to show you the fraction tiles app for the next thing to explore here. So again, we have that idea of partitioning things, why that multiplying by the same number. Yes, it is also a version of 1, but it also gets that chance for that. So here we have the fraction tiles app. I am in the workspace called the wall, and I press this button right here that has all the black rectangles in it because it made instantly in one click all the fraction tiles there to make this to show. Now, I have a task here. Find all the fractions on the wall equal to a half. Now, if you'd like, you could even move this guy over to the piece that you're looking at and thinking about, okay, how many of these would be equal to a half? Now, there are some choices. I could delete any of the tiles that are not the half, right? But also, wait, these thirds, none of them actually equal up to that, right? So I can just highlight that row and I can delete them. With fourths, 2/4 looks like they that would equal it. I also have an option here as I use the rectangle to highlight those. I can toggle off the fill so I can visually see 2/4. And I love when we do the fraction tiles here, the students are seeing those unit fractions, right? That 2/1/4. Remember, we don't want to just call fractions 2/4, 3/4. We want to call it by the unit fraction as well. So what I can see here is that 3/6 or 3/1/6 is the same thing as a half. And 4/1/8 is the same as a half, 5/1/10, and 6/1/12. So again, being mindful of the way we're talking about the fractions and talking about those unit fractions, of course. And then you can assign the students to write in their math journal, what do you notice? What do you wonder? And then I want you to generate 3 more and prove it with a picture, right? So all the time having the kids constructing their understanding, having them notice and wonder as they are working on the mathematics. Now, within this, I use that share code here for this wall, but it also shares on each of the work mats what you have. So I'm about to use an example that will show you that each work mat will have on it some information. And then if you put things on each work mat, you might get 3 tasks with one link. So that's what's going to happen right here. Let's talk for a second about comparing fractions. I want to first go into I'm going to go to the Fraction Tiles app again. But I've actually put something on each of the 3 work mats. So it's not just this one screen I want to talk to you about. So here we have the removing one piece from each row. So it's asking them to remove a piece from each row. So if I either delete it or I can toggle off the color. So I'm going to be doing this. And of course, what are you noticing and what are you wondering? Well, I am getting closer and closer to a whole because those pieces are getting tinier, right? So being able to notice that pattern, this is a comparison strategy in grade 4 that we talk about in terms of a missing piece. So if I am comparing 11/12 to 7/8, rather than having to go to a common denominator, or please don't do butterflies. There is no place for butterflies in math class. That the butterfly method, yeah, it might get a right answer, but it's not having any conceptual understanding. If I think about 7/8 compared to 11/12, 8s are larger than 12s. So if I'm missing a piece, I'm further away from a whole. So that kind of thinking is more difficult thinking. We save that for grade 4 rather than in grade 3. And then having the students in their journal write to you a fraction that's greater than 11/12 and to explain how they know. See if they can apply that. So here on this screen, that idea about that missing piece as being a strategy to think. I want to go now to the basic work mat, and I've put these different fractions here, and I want to order these, let's say. I know in my classroom, I was a grade 5 teacher for 13 years, and I became math coach K5. And that's really when my journey really began in depth of the progression of understanding and all. I would have thought back when I was first beginning teaching, because it's all that I knew is how I learned as a kid, was to try to find common denominators. And it just can be really laborious, right? But what if we use our reasoning? What if we think about the number sense for fractions? If I've built enough of my number sense about these, what can I think about? Well, one of the best ways is to think about a benchmark of a half, right? Are any of these less than a half? Well, now it gets a little strange with odd denominators, but if I were to think of half of 5, that's 2.5, and 2 is less than 2.5, right? So automatically I know this guy is the least. None of the other ones are less than a half. Okay, well, 10/9, wait a second, that's more than a whole. If I've really understood in grade 3 that 9/9 is the name for a whole, then 10/9 must be more than a whole, right? And we don't call them improper at all. We call them fractions greater than 1. So the understanding that fractions are numbers, they are either less than or greater than 1. It doesn't make anything improper about them. It's perfectly fine written just like that. Now, I also noticed here 3/6. Well, that's the same thing as a whole. So if I've had my time exploring and building my number sense, I know that that's equal to, it's equal to a half, right? So I have one that's less than a half, one that's equal to a half, one that's more than a whole, and I have these two guys, right? And can I think about reasonably? Well, 11/12, it is just missing 1/12. It is really close to a whole. So it must be around over here. And 4/7, half of 7 is 3.5, which means 4 is just a little bit more than that. So it's a little bit more than half. So I'm not thinking about partitioning and making equal size pieces here. I'm just reasoning about the size of the fractions. Now, what if I get to the point now, of course, where I can't always reason it through? So here I have Amy ate 2/3 of her package of raisins and Sue ate 3/4 of her package of raisins. Who ate more of their package of raisins and by how much? Now, first of all, we got to remind ourselves about the size of the whole. That it's possible that Amy could have eaten a really huge box and Sue could have eaten a really small box, right? So you got to make sure that in the context situations, it does mention about if Amy and Sue ate the same size raisin box, their raisin boxes were the same size, and Amy ate 2/3 of hers and Sue ate 3/4 of hers, who ate the most, right? So be aware of that when we have contextual problems. It's got to mention the size of the whole. We can't just assume that. So if we're assuming that these are the same size packages, well, 2/3 of Amy, so that would be 2 1/3. So I'm going to bring down 2 1/3, and I'm going to even put it on here on the number line for a second. Remember, this is how we're now going from the area model to that linear model. And now I'm going to go to 3/4. And so as I'm putting these out here to compare, now I can see, yes, 3/4 is greater than 2/3, but we want that visualization, of course, of the pieces. But eventually we're going to get to a point where we're not going to have, we don't want the math tools to do the work for us, right? So we want to think a little bit about, well, what else can we do? We may need to sometimes go to a common denominator, in which case I can think about, well, these fractions here, the 1/4 has gone through an experience of being broken into 4 pieces. And the thirds are going into an experience of being broken into 3 pieces. So I can give the experience to the other fraction, right? So I can put this 2/3. Remember that partitioning of like a geoboard? If I had a picture of 2/3, I could put it into fourths horizontally and see what the equivalent fraction would be. And I could similarly do the same thing with the fourths. I could break it vertically into fourths and then partition it horizontally into thirds, giving the common experience that they're both having a common experience. And of course, it turns out to be 12ths, right? Now, it doesn't need to be the lowest common multiple. It can just be the multiple of those two. So there's no requirement for them to be in simplified form, right? It's easier numbers to deal with, but it doesn't have to be. It can just be the multiple of the two denominators. So I can use this number line to help me as well. You notice right now they're in 8ths. If I choose the arrows and I keep going until I find one that will match both. So here, this 3/4, sorry. So 3/4 is the same as 9/12, and 2/3 is the same as 8/12. Right? So I was able to get them by giving that partitioning horizontally to the other denominator. I was able to experience that and put them into 12ths. And I can even see here that what's the distance between them? It's just 1/12, right? So I can be able to visualize and have experiences going through those. So that'll of course become helpful to us as well as we're adding and subtracting to get into the common denominator. We can give the experiences of the other partitioning of the fraction to make sure that those are getting into a common language. All right, so that's comparing fractions. I do want to say, I just want to show here another example there. So crucial we get this foundational understanding so that we can apply it within the operations. So here I have a square broken into 1/2, and here I have square broken into 1/3. And then I'm going to be partitioning it here. I want to give the experience of the other denominator. So if I was going to compare or add these fractions, well, I have the 1/2 shaded. I can give that partitioning into 3 equal sized pieces because that's the experience of the other fraction. So I can see here that my 1/2 can be renamed as 3/6. And then I also have this 1/3. Now, if I want to partition it into half, so I'm giving it that partitioning experience of the other fraction. Well, now I can see that my 1/3 is the same as 2/6. And now I can compare or I can add or subtract, right, to get in the common denominator. This is really crucial visualization of how I'm getting these equivalent fractions and being able to generate them on my own myself. So with that, then, how can we apply those skills in the context of the operation? So with the with addition, of course, we're going to begin in grade 4 with addition with unit fractions. And it's about the idea of the iterations of the unit fraction. So we're going to have a common denominator. So here in the Pattern Blocks app, what I did to save time, which is why I'm help facilitating this time together by putting it already on the screen, I would certainly spend a lot of time with the students building their understanding of, and I like to define the hexagon as a whole. It doesn't have to be, but I do like how these pattern blocks do fit when it's the whole, that I have my halves, my thirds, my fourths, sixths, and even the 12ths as well. So if I were to model for you how I would add 1/3 plus 1/3, of course, I would drag and drop out 2 of those 1/3. And so again, remember, 2/3 is the same as 2 1/3. 1/3 plus 1/3 is the same as 2 1/3, which is 2/3, right? And so certainly being able to have that, doing for any of the different denominators. Let's say I'm doing 3/4. This app allows you to flip the pattern blocks as well across a line of symmetry. And so you can be able to make it look like the hexagon by doing that. So if I have 3/4 and I'm going to bring out one more fourth, the idea, of course, that means 4/4, which I can then drag a hole on to show it's the same, right? So the idea that we have those as being the same, the 4/4 now makes that hole. Here I'm going to have one going over a hole, right? So if I have my 5/6 and I want to be able to orient that, I'm just going to flip that over and I'm going to drag this out and I'm going to flip that. And now I'm going to just be handling those and I'm going to actually do a copy of that and I'm going to flip it horizontally and that gets me my my 6/6. So if I have 5/6 and then I'm adding 2 more 6ths, doing this for years, I taught with pattern blocks of fractions. I had not been exposed to this visual thinking in my own journey until we had a consultant, Tom Schurston, came to my school, and it began my journey of visualizing with math. I did not realize how much you could teach, that everything you teach visually. And so I remember seeing this 5/6 plus even a 1/3, right? And I could visualize how, 1/2 of that third, I could visualize the equivalent fractions and how one of those 6 can fit right there. And I began not thinking procedurally anymore, right? So we want to think about this 5/6 and 2/6, that 1/6 of the 2/6 can join the 5/6 to make a whole. Or if I'm thinking about 5 1/6 plus 2 1/6 makes 7 1/6, and 6/6 is a whole. So that all that thinking gets tied into here. Now, what happens when I have a half plus a third? So here would be a piece that's the 1/2. Here's a third. Well, if I were to have this half and then break it apart into 3 equal pieces, I would end up having 6ths, right? And so I'll be able to do that equivalency. I'm going into my same common experience, right? It's my same denominator of those 6ths. Let me just get that. And then similarly, if I was to partition this third in half, I would end up having, in terms of the size of the whole, a 1/6, right? 2/6. So that my 1/2 and my 1/2 and my sorry, try to think two things at once. My 1/2 and my 1/3 ends up being 5/6 again. So, different ways of modeling that and seeing that. But of course, now we're getting into our different denominators, but we're always thinking about getting into a common experiences that we're going to be able to have. So with that then of adding and subtracting, there were things that I did not do in my classroom that I wish I could go back and apologize to my kids. That's what Robert Kaplinski says. If you're not embarrassed about your own teaching, then something's wrong. But so I know that when I did mixed number adding and subtracting, I was all about the procedure. And there was a heck of a lot of regrouping going on. And I spent so much time with many of my kiddos to understand why the procedure worked. And I can't say I was always successful 100% of the time. And I would do it so much differently now. So in primary level grades, we deal with whole numbers and using strategies, right, with number relationships and not just going to algorithms too soon to give the chance to build their number sense. So what if here we're in the number line app and there's a work mat within it on fractions. So if I want to add 2 2/3 plus 1 2/3, yes, I could add the wholes together. I could add the fractions together, but then this might feel a little strange because 2/3 and 2/3 ends up being 4 1/3. But instead, what if we gave that and even have it become mental math for our kiddos by having that be on like a number talk? What if I rounded and adjusted? So if I put a pin on the 2 2/3, now I adjusted the range on this number line by down below here. So you'll notice you can either set the beginning numbers, beginning and end, or you can just glide this along the number line. You can click on there and drag it. And I chose to have the denominator show in thirds right now. So I'm starting on 2 2/3, and I want to add 1 2/3. But 1 2/3 is a little difficult. I mean, it just looks a little wonky to me. It's kind of close to 2, and that would be easier for me. So what if I go ahead and jump 2 wholes? And so I can adjust this arrow, and you can notice up here, it's showing me what that distance is. So what if I jump 2 wholes? This can eventually become an open number line, right? Where I would just do 1 jump, going ahead 2, and I would record the 4 2/3. But I wasn't asked to add 2. I was asked to add 1 2/3. So I need to come back a third. I had rounded up a third. I need to come back that third, which means that I've landed on 4 1/3. That must be the answer. That must be the sum for this, right? So one strategy we can use with the numbers is to round one of the numbers and then adjust. What if I want to add by place value? So again, I'll be on 2 2/3. Maybe I want to add the 1 first. If I add 1 to 2 2/3, I end up being at 3 2/3. And then I could iterate the 1/3 and the 1/3 if I wanted to, or I could adjust it and have it be 2/3. But then again, I've landed now on that 1/3. And finally, for the addition, what if I want to decompose to a friendlier number? What if I think about 1/3 of this 1 2/3? That gets me to 3 whole things. And then I can add 1 and 1 more third. But adding 1 and 1/3 to 3 isn't that hard, right? I don't want to say easy and hard because what's easy for some isn't easy for others, but it makes it friendlier numbers, right? There's more likelihood that the chance is going to be relatively easier. So I broke apart my 1 2/3 into a 1/3 and a 1 1/3 to enable me to then do this in a more efficient way. Now, when I'm broken apart that 2/3, I thought I forgot something. The decomposition of fractions is important because if I haven't done this work, then I can't do that strategy. Let me just show you for a second with the Cuisenaire rods. I love the Cuisenaire rods because you're able to rename the whole. When you're using the fraction tiles, the labeling of the fractions on them is limited to that red rectangle being the whole. But in Cuisenaire rods, we can have any size be the whole and all the fractions will adjust. There's a fraction work mat in here. Now, Cuisenaire rods are my favorite manipulative. I think they're the power to bring us, our students forward from the counting phase of reasoning into additive reasoning and from additive to multiplicative and then to proportional. It really is a versatile math tool. There's a color coding system, which is trademarked by Hand to Mind. But the 5 and the 10 are benchmarked. Those are hot colors of yellow and orange. Your warm colors are 2, 4, and 8 because 2 doubles to 4 and 4 doubles to 8. And then you have multiples of 3. Light green, dark green, and blue. And then the white and the black are the 1 and the 7. And so those will help our brain retrieve from memory what the relational rods, and they're also relational. So I have kids build this staircase, and rather than labeling them with a number, I say, well, what rod must this be? It's 1 less than 10. If we know our benchmarks of 5 and 10, or half and whole, right? But I can make any of these be the whole and see if I can find a rod that is half of it. But let me just go for a second into the fractions work mat. So if Jen has 7/8 of a yard of ribbon and some of the ribbon is red and some is purple, what are all the possibilities of the amount of colors of fabric if they come in 1/8 yard pieces? Well, if I get out my 7/8, I could have all of it being red, right? But then I also could have 6/8 that is red and 1/8 of the purple. Now, this is going right back to when we did whole numbers and we decomposed the numbers up to 7 into 6 and 1 and 5 and 2 and 3 and 4, right? That's exactly parallel. The experience of fractions is parallel to the whole numbers. You can also see where the commutative property is kicking in. You'll see there's a pattern going on. The students can notice the pattern that as one is going up the other by 1/8, the other one is going down by 1/8, right? I just need to think for a second as I do this. All right, and so, wait, I need to make the pattern look right. So this is the, sorry. So you can see that there's a pattern happening here, right? So as you end up having an upside down staircase. And once I make it back to the original amount, I know I found all the pairs of add-ins. So I did these two backwards. So you can get the visual of how when one is going up by unit, the other one is going down by the unit. And so you end up having a staircase, right? And so this is parallel then to the whole numbers. And once I've done this, then when I'm doing adding of fractions, I can decompose a fraction. I can combine it with my first add-ins to make a friendlier whole number, and I'll have the leftover piece of that to add on to the whole number. So that's another really important piece in grade 4 that we do that. So what if we, I'm going to show you this just for 1 second, just because I have to. So I'm going to show you this for a second, although we're not going to do it visually. I want us to just think for a second. Okay, so if you were to think about having your students add 4 8s and 7 12s. Now for me, in my 5th grade classroom, I would have expected, because I did not know anything different, to find a common denominator, right? And then the children are running out the multiples of 12, the multiples of 8, trying to find the one in common. Yes, it would be 24, but what if for a second, if you've had your number sense built of benchmark numbers, if you think about 4/8 and 7/12, isn't it true that 4/8 is the same thing as a half, right? So if I were to bring out 4/8 and then I bring out 7 of the 12ths, oh, come on. Well, is there a 1/2 within the 7/12, right? Isn't 7/12 the same as 6/12 and 1/12 if I've decomposed it? Which means that if 4/8 equals 1/2 and 6/12 equals 1/2, then this total must be a whole and a 12th. Right? We can open the door to so many more people in this journey of fractions when we're giving a chance to explore these things and not rushing to algorithms and procedures. Alrighty, so with the pattern blocks, I had shown you with adding of the numbers, as well as even with a different denominator, the idea that we can be exchanging to common denominators. And then, of course, with subtraction, one part of understanding subtraction is to remove the items. But another meaning of subtraction is to think about adding up, right? Thinking about the distance between those two numbers. So I'm going to go to this number line, show you some strategies for subtracting. Because again, these are things that I did not do in my classroom that I wish I had done, because it can open up that idea of even doing mental math with these calculations. So if we, let's say, had 4 1/4 and we're subtracting 1 3/4. Now, certainly students think about subtraction many times as removal. And so they could be starting on 4 1/4 and they could be rounding and adjusting again, right? This can round to 2 whole things. I could jump back the 2 whole thing and I can go back 1/4. That gets a little, we got to see that visually. So 4 1/4. If I come back 2 whole things first, well, that distance of the 2 wholes is 1/4 too much. So I need to come back the 4th. So the number lines really help the students see why this kind of a strategy is working, of that rounding and adjusting. I certainly could subtract by place value. I could subtract 1 and then 3/4. But I do want to show you the real power we have of thinking about the distance between the two numbers, because sometimes the numbers, because in subtraction particularly, the numbers dictate for me what strategy I want to use. I might remove the subtrahend, or I might think about adding up, depending on whether they're close together or far apart. So if I'm on 1 3/4 right now, and I want to think about the distance to get to 4 1/4, well, I know it takes 1 more fourth to get to a whole number. And now I can go from that 2 all the way up in one jump, right to 4 1/4, right? It's 2 1/4. From 2 to 4 1/4 is 2 1/4. And it's just 1 more fourth to get there. And I didn't need to regroup and change a whole number into 4/4 and add it to the 1/4 I already have here. That's where I lost a lot of my kiddos. There were many of my kiddos that were fine at that, but there are also many that weren't. And then it became yet another reason why they thought they weren't a math person. It affected their math identity. And it became a self-fulfilling prophecy and moving forward. And they were locked out. I mean, think about now STEM careers and how much we need mathematics, right? And one more thing I want to show you too, that's also crucially important, is this same difference, that distance is the same. So if I use this tool here to show you that the distance between 1 3/4 and 4 1/4 is 2 1/4, but this distance isn't going to change. I can move it along my number line, right? So what if I take this distance and I move it here? So this problem, this 4 1/4 minus 1 3/4, can be renamed as 4 2/4 minus 2. That's a lot easier. If you were to ask me to do a mixed number subtraction problem, I pretty much now just get my subtrahend to a whole number. I rename it to easier numbers to work with. I don't have to go into any of that regrouping or anything. All right, so that is addition and subtraction. That is a lot within addition and subtraction. With multiplication and division, as we're continuing this journey, we also want to think about, we have begun in grade 3 as being unit fractions and the iteration of those unit fractions, right? That a 3/4 is made up of 3 1/4. They'll begin writing that as an equation as 1/4 plus 1/4 plus 1/4. And as they are working on their journey with multiplication, recognizing that as repeated addition, that a 1/4 and a 1/4 and a 1/4, making that 3/4, I could write that as 3 times 1/4, right? That part of multiplication. So if Catherine painted a set of 4 chairs and each chair requires 1/8 of a gallon of paint, so I had 4 chairs, each having 1/8 of a gallon, how much of her gallon of paint did she use? So she had 4 chairs, she used 1/8 in each. Well, how much is that in a whole? Well, I could think about, well, this rod here would match up. It's just going to be 4/8. If I want it to show in simplified form, I can click this button. So 1/2 is the same as the 4 1/8 and 4/8, right? I've just made that iteration. So I could think about it as being 4 times 1/8. I have 4 1/8, which is 4/8. Now, what if we get to be having not unit fractions now, but other numerators like a 3/8? Well, what I love about Cuisenaire rods is they allow the children to see these things existing as a group and not just as a collection of ones. There is a place for that. Kindergarten is counting and cardinality. They live in the worlds of counting one by one. But in additive thinking, grade 1 and 2, we want to try to move them to work into groups. It's parallel with fractions. They're going to begin 3rd grade working with unit fractions only, and then the understanding of the composition of fractions with unit fractions. But in grade 4, we can now be using tools that are showing that existing as a group, that I have 3/8, 3/8, 3/8, another 3/8. Well, how many 8s is that? Well, it's 12/8. I have 3 plus 3 plus 3 plus 3, right? 3/8 plus 3/8 plus 3/8 plus 3/8. I can think of that as 4 times 3. I've got 12 1/8, which is 12/8, right? So think about that connection all the way through as we're working on those. Then also thinking about multiplying a fraction by a whole number. So that's within the work mat in this link for you. If I go to the basic, because this was multiplying a whole number by a fraction. It's like 4 times 1/8. It's 4 of those 1/8. But we also have multiplying a fraction by the whole number. I think I put it under the whole numbers here. So Kylan had lots of toy trucks. If half of her toy trucks are excavators and she has 8 toy trucks, how many are excavators? So if I want to take out my rod, this is worth 8 units. So she has 8. How much would half of it be? Well, I can be experimenting and trying to find which of these rods is equal to half of that whole. And it turns out to be 4, right? So half of 8 was 4. If Kylan had lots of toy trucks and 3/4 of her were excavators, well, this gray button here in the Cuisenaire rods is one of the benefits of doing it virtually, because in the physical world, you don't have the ability to adjust certain tools. So this tool is 24. And I can think about, well, 3/4. I need to partition this into 4 equal sized pieces, right? Now that's what I can think about. Well, 24 divided by 4 is 6. So it should be that if I partitioned this into 6 equal pieces, this is where great concrete for the tape diagrams, bar models, right? Which I love. It unlocked for me a lot of the middle school mathematics by thinking about bar models and tape diagrams. So here we have the 4/4, and each of those being worth 6, but I'm missing a piece. I'm missing a 4th, right? So it must be 18. And I could, if I wanted to, drag out a gray one and have that be reaching out there, right? So I can visually see that 18 is 3/4 of 24. So the multiplying by a whole number by a fraction and a fraction by a whole number. And then what if we get to fraction by fraction, right? So talking about fraction by fraction, I'm going to use that geoboard again. I love the geoboard for constructing the understanding. So if I have this, again, area model is the best model we can use for multiplication and division and fractions. It's going to unlock the journey for our kiddos. So Kathy's baking a recipe and it requires 1/3 of a cup of brown sugar, but she's only making half a batch. So how much brown sugar will she need? Well, if I have my whole, right, I'm going to make that into thirds first. So I'm going to partition this into thirds so I can and then I can shade in one of my thirds. So by using my bands, I can be connecting those. I can then I like to use the highlighter. I can use the highlighter and I'm going to make it big and thick so I can do it faster. I'm going to shade in for you 1/3 of a cup. So 1/3 of a whole cup. Now, if I'm only going to use half of it for half my batch, well, I could either partition it with my pen if I wanted to, or again, taking down a band and partition it into 2 equal sized pieces horizontally. Well, then what is the value of this piece here? What piece is 1/2 of 1/3? Well, it's 1/6. We got to think of it in terms of the whole, right? So this area model here of getting equivalent fractions, and then also it then extends itself to multiplying fractions as well. Please know that I have been on this journey for years. And when I first began seeing fractions, I remember when I was working with a consultant on those pattern blocks, my mind was not seeing it. And I was getting frustrated with myself because I thought I was a math person and I was used to catching on really quickly to math. And I was put in that place of productive struggle. But now I know that that was good for my brain. It's good for your brain to have that productive struggle. It grows those new neural pathways. And now after practice, it's solidified in my brain. And now it does seem easy to me, but it didn't always seem easy to me. And so it's just part of that math journey that we want for our kids, right? All right, so 7 minutes of division. So let's first of all talk about how in grade 5, we want students to understand that fractions is another way of representing division, right? So if I go to this app here that we're kind of be understanding, again, fractions are a way for us to express division. So let's say I've got 2 granola bars. And so these 2 granola bars were shared by 2 people. What would be a fair share? So we're thinking about a fair share. We're taking this amount and splitting it apart. That's the first meaning of division of these partitioning, right? This partitive thinking. We're fair sharing. So if I had 2 granola bars and I'm sharing it with 2 people, each person can get 1 piece, right? One whole granola bar. Well, what if I have these 2 granola bars and I'm sharing it among 3 people? Well, I could break apart each of the granola bars into equal sized pieces, right? Because remember, fractions are equal sized pieces. So I can break it into 3/3. Now, I can then give 1/3 of each of the granola bars to each person, right? Each one of them gets 1/3 of the whole. So they get 2 1/3 or 2/3. Here's 2 granola bars shared by 4 people. So if I did my fourths, I would break it into 4 equal pieces, right? And I'd be able to give 1/4 from each of the granola bars to each person. And then if I have 5 people, well, I'd have 5/5 for each of the wholes. And I could give each person 1/5 of each of those granola bars. So what's happening here? Well, what if I think about this? That when I had 2 granola bars and they were shared by 2 people, everyone got 2 of those wholes, right? When I had 2 granola bars and I shared them among 3 people, each person got 2/3. Here I had 2 granola bars shared by 4 people. They each got 2/4. And here I had 2 granola bars shared by 5 people, and each of them got 2/5. This is something that I did not learn until very late on my math journey. It was mind-blowing to me that if you give me a word problem now that says that there are 9 candy bars and you're trying to share it among 11 people, how much can each person get? 9/11ths, right? It's that journey of understanding that the number of things that you have divided by the number you're partitioning it between, that's just another way in the fraction form to represent that division. So we want the students to have experiences, of course, doing that and come into that conclusion on their own, that we're not just telling them that, right? It's so important in the math journey that they do that. And then there are 2 more ways that I want to go through tonight for division with fractions. And the first way is to divide a whole number by unit fractions. This is specified in grade 5, dividing a whole number by a unit fraction. Now, this is going along with the quotative meaning of division, which means I know the size of the group. In fair share partitive division, that we know how many groups, we don't know how many each person gets. So we're kind of fair sharing it. In quotative division, it's a measurement version of division, we know the size of the piece. So if Matthew was going hiking with some friends, and his snack recipe measured 1/4 cup of peanuts for it, if he has 2 cups of peanuts, how many friends can he make a snack for? So if I have this, my 2 wholes, now I've just chosen here for the brown one to be a whole this time. But again, you can choose what rod you want to be a whole. You can do that right here. This button here allows you to choose any of the rods to be the whole. And then all the fractional amounts, when you choose to have them labeled, will be in relationship to whatever you've defined as a whole. So people call these rods relational rods because of that as well, right? But they are trademarked by Hand to Mind. So here we have these two wholes. And I know that if I had 1/4 of a cup, that would make enough for one person, right, in the recipe. So I want to think about, well, what rods could I fit 4 equal pieces? And so I could think I have these, right? So 4 equal pieces here. And then if I want to show you the fraction, I can label all. I'm going to go down to simplified form, right? So I have 1/4. So I have then seen that there are 4 of those 1/4 in that hole, and there are 4 of these 1/4 in that hole. And so it turned out that my my 2 cups, when I divided it by 1/4, it turned out to be 8. And I didn't do anything with Kentucky Fried Chicken. Keep, change, and flip, right? I didn't do any of that. That's a trick. And it's something the kids are going to forget and not know why it was working, right? We need to have the experience to understand. We can get to the understanding that I can, if I'm dividing by a 4th, it's the same thing as multiplying by 4 and its inverse, but we get the kids to get there by constructing it and not by teaching them. There's no place for Kentucky Fried Chicken in math either. So all righty, so we have these unit fractions here. And then one last thing that I wanted to share with you here in the app would be the partitive thinking again. If I have a fraction and I'm dividing it by a whole number. And so that I want to show it to you here in the GeoBoard, where I'm able to do that partitioning myself and feeling that constructing piece of it. So I have a 1/2 cup of paint and I'm sharing it equally between 4 students. Well, I'm going to take that amount and I've got to partition it equally into 4 equal pieces. So I'm just going to do that again here with my bands. But then I've got to think about what part of the entire thing is that fair share. So person 1 is going to get this piece, and each of these 4 students is going to get that equal size piece. Well, what is it? How much is this in terms of the whole, right? It's 1/8 of the whole. Also happens here, if, let's say we have, if we have 2/3 of a cup of paint split among 4 students, creating this visual is just transformational for every brain. Remember, I was not a visual learner. I thought I didn't have a visual brain. Totally do now. I've changed the neural pathways by practicing it and thinking it. And there have been times that I productively struggle. Like I look at it, what am I doing? So here we have, again, the partitioning here. So I had 2/3 of a cup of paint. I'm splitting it equally among 4 partitions. So what was the fair share, right? It was 2 of these 12 pieces, right? All right. Now, one last thing I want to share with you tonight. I know this has been a whirlwind of a journey, but there is nothing elementary about teaching elementary math. I wanted to show you that there is a way that you can be having this be a collaborative environment for your students. I love using the Google environment. So Google Sheets. I do a lot of my presentations and my trainings, so seminars. I present for Bureau of Education and Research as well. These virtual trainings, I want to get people interactive with the math, right? Math is not a spectator sport, as Dr. Nikki Newton says. So this file here, what I did is I did a training with a district a while ago, and I was talking about fractions. We did a fraction focused seminar, and I gave them this 1-word problem, and I asked them to go to a manipulative of their choice and solve it. And then what they did is they pressed the share button, but rather than choosing a code, they chose the copy image. And I gave them the link to this Google Sheet, and they pasted their image here. So this is a way that students can then be sharing their own thinking, right? There is not just one way of doing things. So I don't want to always assign that you must use this manipulative to solve this problem. There are times you can give them the problem and have, as you would in a classroom, the students can choose the math tool that they think is most efficient. That's one of our math practices, using math tools strategically, right? And so you can see a variety of ways. Now, if I were to be teaching in the classroom, I could even doing the 5 practices, Peg Smith, the 5 practices, the idea that I can be taking the work of the kids and then I can be putting it in a certain order, building on complexity with the students the next day to talk about the thinking and what is the same and what is different about what the students have done. right? So you can then be seeing all these different ways that students have come to the conclusion that with the word problem that no, Kylan would not have enough to make her badge. But you can see how people use the fraction tiles. They even did a fraction tile together with the number line, or this person happened to use the colored tiles, thinking about kind of like a ratio there. And here, this person used number line. So it's not having us think about making the students use a certain math tool, but opening up the door to have them using tools that make sense for them, that can efficiently show their work. It's all about having the kids having their thinking become visible to us, right? Using these math tools are about the mathematics, the strategies we're doing with the numbers being visible with these different models, and Branding Camp being an amazing suite of tools for you to be able to do that. All righty, so that is progression part 2 of the fractions grades 4 and 5. So I'm happy to answer any questions that anyone has. I don't know if my support team here has kept track of any questions.
Yeah. Oh, excuse me. Yeah, Annalise, there was one question that came up that I saw about getting a copy of your presentation. I don't know if that individual meant the Word doc, or I should say the Google Doc.
Because the Google Doc is for everyone. There's that code. I can put the code back in the chat bar again for it. If they didn't happen to get that.
I can put it in there as well.
Someone's asking about getting a recording. Yes, this has been recorded. It will be joining the other webinars on the Branding Camp webpage. When you go to the Branding Camp webpage, one of the links at the top says webinars now. Is a relatively new added page. And you have all previous webinars. We have another one coming up next week with Mark on algebra tiles. So those are all available for you to be able to watch. And I know, please know that my brain took time to absorb all of these different understandings. And so wanting to be able to show that with you and share that with you, but I know it's only an hour I've done that with, but it takes time to kind of build that thinking, and that it's worth the journey. These webinars are free to the public, yes. So on that page, you have the part 1 of fractions. You also have one I did on the progression of addition, kindergarten to 5th grade. And there'll be other fabulous presenters coming on board as well to present these webinars. So make sure that you are following Branding Camp on the social media and by email, so that you can find out when those are happening and who will be presenting. To change the size of the rods in Cuisenaire rods, at the very bottom of the page, it says whole, label the whole. And when you click on that, it allows you to choose any of those 10 rods.
Yeah, so I mean, one of the best things to do is just get into the apps and play around with them. Figure out what things do, and just have some fun and play around with them. And then, we've got that great source that Annalise shared with us to her Google Doc with those share codes. And like most great teachers, we take things and then we make them our own. So thank you so much, Annalise, for putting together those great resources. I'm exhausted, and I was just listening for an hour and watching. So thank you so much. That it is just it's just a pleasure to see your passion for math education, for mathematics, for the whole, for the teachers, and just for everything you do. So we really, really thank you. I see somebody mentioned that their brain grew. Yes, mine as well.
That's right. That's right.
And just a reminder, I've been putting it in the chat. If you have questions about any support, you can contact us at support@brainingcamp.com or sales@brainingcamp.com if you have questions about getting a license. And I know I shared my email with a few folks. I know Ryan did as well. And I know Annalise, you've got the link to her website and her contact information. So if there's no other questions.
Well, someone was wondering about the fraction part 1. I don't have it offhand, the fraction part 1 share codes. If you email me at aer@annaliserecord.com, I can certainly email that to you. I don't know it offhand. And I'm going to post again in the chat bar as comments are coming in. It's hard to follow and it goes fast. I'm going to put the link again to tonight's share code document, that Google document. It's going to make you make a copy, and then it's yours. the code second half, when you go to the web page, you want to click on redeem, and then you put in the code second half. Now, students cannot at the moment share in real time. What can happen is that they can generate a new share code and give it back to you, so that if you have assign them a task, they then get that and they manipulate the apps, and they put their name in it as well. And then they can create a share code and share that code back with you. My email is aer@annaliserecord.com. The Kentucky Fried Chicken is, there is a shortcut trick of KFC, like keep change, or KCF, I guess it is. So I think of Kentucky Fried Chicken when I think of that. So we don't want to do the keep change flip. Kentucky Chicken Fried, I guess. Yeah. Oh, thank you, Margie. Is that Margie Pierce? I can't see the last name listed, but I'm thinking it's Margie Pierce. She's the kindest person on Twitter. Follow Margie Pierce. She's a wonderful math educator. Keep flip change. Yeah. Is it KFC? See, I don't do it anymore because it's not okay. The kids need to do the thinking. Oh, Margie, I'm glad you're here. Thank you. Please feel free to email at any time, any questions that you have. Happy to help out. Thanks for joining in tonight.
Yeah, and thank you, Annalise, for that wealth of knowledge and passion. And again, if you missed part one, go to our website. You can watch and listen to part one. If you want to listen to part two again, that'll be posted within the next couple of days. And then, if you just keep checking that website, our website, we're going to have we've got algebra tiles next week, and then we've got some we're building out schedules. We've got Zach Champagne coming up, Jennifer Bay Williams coming up in a couple of weeks, and Mike Flynn. So really exciting times here for us at Braining Camp, and for you as well. So before we go, I just want to thank you for everything you do. I know this has been an incredible year for everybody who's in the classroom. My wife is a special ed teacher, so I understand the challenges that we're all seeing and rising to the occasion to meet those challenges and do what's best for kids. So thank you, everybody, for attending tonight.
Take care, everyone. Suzanne, I'm not sure about the redeem being on your phone. I'm not sure how it works on the phone. Take care.